eCybermission Team 360 Vision's presentation. Thank you all for coming tonight. Today we're going to talk about the details of the competition in general, which is eCybermission, our project, our proposed solution, and the contributions to the community, which is you, and the various experiences that we gained throughout our journey. So we thank you all for coming, and we hope that you learned something new today. I'm Rachel, and I'm a freshman at Thomas Jefferson, and I'm also the manager of the team.
I'm Surukava. I go to Chantilly High School, and I'm the analyst for the team.
I'm Malika Manipati. I also go to Chantilly High School, and I'm the engineer of the team.
I'm Divya Shahan. I'm a freshman at TJ, and I'm the lead researcher of the team.
So here's our agenda for tonight. First, we're going to meet the team, which is us, then give a brief introduction to eCybermission, then the start of our mission, our journey, the technical components of our proposed prototype, the benefits to the community, which is safe, what we learned and our experiences, and a few questions that you may have, and conclusion.
I joined eCybermission because I felt that, well, basically I just really like the whole concept of finding a problem in your community and working together within a team to solve it. So it just really appeals to me. So
I joined eCybermission because I have an ardent interest in the STEM field, and I already worked with these other team members before, and I just thought it would be interesting. So like that when we collaborate our ideas and come up with like solutions together.
This idea of applying STEM in the community for like practical uses really struck me, and that's why I wanted to join this team.
For me, I've always really been interested in STEM and in English, and I feel like eCybermission was the perfect magic to combine both of them. So for me, since I've done this before, it was not only of an opportunity, it was more of like a magic coming together, and I think that that was really special. Also, as Phil Jackson once rightfully noted, the strength of a team is each individual member, but the strength of each individual member is the team. Our team is composed by 4 determined individuals, and we all share a bond, which has not only enabled us to complete the mission folder in a more efficient and thorough manner, but also gained extensive knowledge on the issue which we sought to solve. We are all former RRMS students, so we have worked together before, and so I think that throughout this journey, we proved to ourselves that we had a really nice working with each other, and I think that was honestly the best part. So now Luca's going to discuss a bit about the eCybermission competition in general.
Yeah. So you must be wondering about what eCybermission is. Well, it's an online competition that uses the STEM principles. The STEM is an acronym for Science, Technology, Engineering, and Math. And what you have to do is you have to propose a solution to a problem in your community, and then create a prototype on that solution, and document all of your experiences in the mission folder. The mission folder is composed of questions that you have to use to elaborate on your project, and this entire eCybermission project is targeted for grade levels 6 through 9, and it's a really fun experience.
So the start of our mission. Every team has to have a topic to base off of, and however, like most groups, we also hit a wall. We struggled trying to think of an idea. So to help us, we wrote over past mission folders and looked at brainstorming webinars and tutorials to help extend our brainstorming sessions. And during these brainstorming sessions, we would look at the problems in our community and try to think of ways we could use STEM to help solve them. And so when looking upon problems in the community, we found one problem, which is rear view systems. So there's a short video. Is it in Chrome?
Yeah.
It was October 2002 when Dr. Greg Goldbrand got into his car, checked the mirrors, looked over his shoulder, and reversed.
So I looked down, and there he is, 2-year-old boy, in his pajamas, never forget it. His arms was dragging, looking straight up, bleeding profusely from his head. That's a pediatrician. I knew right away. I knew right away I'd lost him.
He accidentally ran over his son Cameron. In 2008, Congress passed a law in the child's name requiring the Department of Transportation do something to prevent backup accidents. But more than 2 years past the congressional deadline, still no action. Goldbranson and 3 safety groups are now suing the government, calling for mandatory rear-view cameras in new vehicles. This PSA shows what a driver can miss without one.
Behind the vehicle are 62 children, and not a single one could be seen.
Never drive a car forwards with the same poor visibility that we have going backwards without a camera.
The government says more than 200 people are killed and 18,000 injured every year in back-over crashes. Goldbranson now has a video system in his SUV. He has no blind zone, but he says until all new cars are required to have rear-view cameras, more children will suffer the same fate as Cameron.
It's effective, it's available, and it is worth a fraction of what I would pay to have my son back.
I know that when I watched this video, I was really touched by it, and I think that all of our team members were, and I think that was what really, like inspired us to pursue this type of project.
Okay, so although there was a mandate passed that like all new cars should have rear view cameras in 2008, it was further pushed till 2011, and now it's been pushed again till 2015. So we're gonna have to wait another year. And so right now, like as of today, 70% of all cars, 7 out of every 10 cars have rear view cameras. But that's only new cars. We still have to look at all the old cars that people have. And so as you saw, like problems in like today's rear view cameras are the angle. As you saw in the video, that one of the cars missed 62 children sitting behind the car. And so the goal of our team is to utilize the latest technology to make a cheaper rear view camera that can be put on both old and new cars and get a better angle and more advantages. Wait, no, stay on. Go back. Yeah, okay. So, So in order to learn more about our topic, we devoted our winter break to learning more about technology. So every day we'd assign each other books of chapters of interesting books and present to each other about what we learned, and we ended up learning a lot. So in today's cars, most of you who recently bought Mercedes and BMWs will see these features, but most cars don't have them. So some of the latest features in cars that provide visibility are infrared night vision and adaptive headlights. So usually in normal cars, headlights, there's only one, so it only goes forward, the beams. But in these adaptive headlights, as you're turning, there's going to be 2 holes, and the light will rotate so that you have a better angle of the light. And another latest feature is lane departure warning systems, which are basically sensors on the sides of the cars that tell you if you're moving. So when you're switching lanes, it's easier to tell. And then another one is reverse backup sensors, which are what most automakers are moving towards nowadays because they're cheaper. But the only problem with them is that you don't get as good of a view. So these ones, they just beep. If there's something within 50 meters, an obstruction, they'll start beeping. And next. Okay. So then, we also looked at how old computer systems could be revived with new technology. So in New York, in one school county, they updated all their computers successfully in such a low cost. They did this by installing new servers on all of them, and then you could just download software from the servers. And so this was a really quick, cheap way of updating all the computer systems. And so we also looked at the difference between microcontrollers and mini computers. So microcontrollers have one function and they do it well. But mini computers are, although they cost more, they can do several functions at once. And an example of a microcontroller would be boards like the Arduino board, and microcontrollers, mini computers would be the Raspberry Pi. And so for our project, we decided that the Arduino board would be better for us because we only had one sole purpose, and that was to get a good view. And So in order to learn more about the Arduino, we bought the Arduino kit, and in the kit we completed several circuits. So some circuits use spun motors, and some use shift registers to turn on and off lights. Some use push buttons to turn on and off lights, and then some use touch sensors to turn on and off lights. And so we also looked onto basic technical components, which Malika and Saru will go over later. And so those include capacitors, resistors, and stuff. Most of you guys will get familiar with this in like your technology classes in high school. And so then we started looking at the current technologies out there that might be able to help us. And so that's when we came upon the Adafruit CC3000 Wi-Fi shield. And it basically allows you to get Wi-Fi from anywhere and anytime. So, and yeah. And then there's another thing out there called iFi, which basically, once you take pictures from a camera, it automatically sends them to your phone. So we thought that we could somehow connect using the camera to your iPhones and Androids out there. And then we also looked upon the miniature TTL serial JPEG camera, which is probably the size of a quarter, and it basically is enough to provide you with JPEG images as you're backing up. And so our solution involves a connection of all three components: iFi, Adafruit, and the camera. So then we also looked onto basic C programming just in case we wanted to develop an app. And so we also looked onto shields. And shields are basically additional attachments you can add on breadboards. And like you can add like Wi-Fi shields. They basically just like snap on top of the board. And so Malika and Saru will talk more about the components.
As Divya was mentioning before, when we were testing the Arduinos, we used lots of different elements, such as the capacitors, resistors, wires, and transistors. Resistors are basically, they're used to control the flow of current that go to sensitive components such as LEDs, as you see here. And the LEDs are very sensitive, so you need to control how much goes to the LED, otherwise it'll burn out. We also use wires, which allow the flow of current to pass through. And we also, when we were testing, we also use capacitors, which are kind of like a battery, and they store quick energy. And finally, we use we use transistors, which are basically like semiconductors that amplify the current and switch it also when needed. And they're used in most of the electrical devices that we have today. So we use some of these parts, like the resistors, for our Arduino camera. Well, there are many components that we had to put together, and they all had to work together in order for our contraption to work. Actually, our prototype is right there on the stand right there. And yeah, so there were lots of technical components that we had to make sure every single part of it worked, so that the entire contraption could work as a whole. And the most important part of it that I would say is the Arduino Uno. And Divya mentioned it before. It's basically a microcontroller. I mean, if any of you have done First Lego League or First Tech Challenge, you'll know that you have an NXT Mindstorms. And what does that do? It's kind of like a brain. It sends, it delegates the power to all the other electrical components. And that's basically what this microcontroller does. It delegates the power and sends out commands, so it acts kind of like a brain, exactly as an NXT would. And well, what exactly is a microcontroller? It's in some ways you could say it's a lot like a mini computer. But the main difference between a microcontroller and a mini computer is that in a microcontroller a microcontroller serves only one function. So although it can do just one thing, you can program it to do just one thing, you can program it to do that thing very well. And it can be really useful, this type of thing. It's also, the Arduino is really low cost, like about $35, so it's accessible to the community, more practical. So, well, what was our function? What did we use that one thing to do? We programmed our Arduino Uno to take pictures. So what the prototype does was it connects to Wi-Fi. It opens up a web server using the Wi-Fi shield. Divya and Malika both mentioned shields before. There's one on
the corner right there, that's a Wi-Fi shield. And what it does is it allows the Arduino to connect to the Wi-Fi. And then once we had that, we were able to connect to a web server. And then the the camera that was also connected to the Arduino the Arduino would use the Wi-Fi and to send the pictures that the camera takes onto the web server that you open up on your display. And it would automatically upload the pictures using the Wi-Fi. So that's how they all work together. And you could easily reprogram this microcontroller to do something completely different. And since it's so cheap, you can just go online and search up Arduino projects, and you'll just find dozens. Like there were some. One of them I can recall is they turn on a thermostat in your home remotely via the internet, and you can do so many things with it. Yeah, and why are microcontrollers attractive? I mean, we could just have a complete camera and just put it in the back of the car. Well, once you have microcontroller, you can do various things with it. And as I said, you could put on the Wi-Fi shield, use that to do different things. And there are lots of other things that you can also attach to LED displays, tons of stuff. So it's very, since it's so, it arrives to you at the most basic level, so that you can add on to it and make it anything you want. So that's one reason, and it's cheap. It also has a very small carbon footprint. It uses really little energy. There was one time where a certain group, they used the Arduino to teach a full computer science course in a third world country. As you can imagine, in these type of places, you don't have very reliable electrical power, if any at all. So they were able to use the Arduino the entire time without recharging the battery even once. And as you can imagine, it can be very helpful in these places. So, yeah. Okay, so, well, actually, we want to talk about the other components that we have.
Yeah. So, as elaborating on the shield, it's a shield placed on the Arduino with pin header extenders along the top and bottom sides. And the connections can still be reached, it's just at a higher level. And the Wi-Fi shield connects to a network, and when the camera takes a picture, it sends it to the network through the network and to the display screen that we have on, like when we connect it to the Arduino.
Okay, so just going off on a bit of a tangent here about Wi-Fi. Many of you may notice these things before. If you're setting up a router, you'll have like a drop-down list where you choose one of these options. So what are they? They're basically wireless encryptions. They're security algorithms that you use to protect your network. Why do you need security? Why do you need to protect your network? Because what people do is that if you're able to hack into a network, then if you get the password, you can use that network to conduct illegal activity. So once the police investigate things, they'll come knocking on your door because the illegal activity was done using your network. So you want to make sure that your network is secure and that it's accessible to who you want it to be. And these are all different encryption standards used to protect networks. And so which one of these should you choose? What you want to do is choose the most updated wireless, like the older standards that we have here, they are more at risk into getting, into being intruded than the newer ones. So it's really recommended that you update, or you get the most recent wireless encryption possible, or if you can't, you can just, or if the most updated one that your router can support, and if you can't do a very good one, then you want to update your router. And there are many types of wireless encryptions, 3 main types, and you have, the first one is WP. It stands for Wired Equivalent Privacy, and it's the most widely used security algorithm in the world. Part of this is because it's like the first thing that you see in the drop-down menu, but yeah, it's been around for a while, so lots of people have had it. And the problem with it is that it has a lot of flaws in its security. FBI, actually in 2005, they conducted a public demo where they hacked into a network protected by WEP in like 2 or 4 minutes. And you can see why this is a big problem, because they used the software they used was free. They just found it online, and they were able to hack into this network. This is not good. So, and despite many improvements, it has serious flaws, and it was compromised by the Wi-Fi Alliance in 2001. Yeah. And it was replaced by WPA. WPA stands for Wi-Fi Protected Access. And it has significant improvements. This new wireless encryption, it had wireless keys with more bits. Wireless keys are it's the password that you use to protect your network, and it's a security code. And what WPA did was use 256 bits, and while WEP used 128 and 64 bits, which was found out that clearly was not enough. And it also had other things, like it uses TKIP, stands for Temporal Key Integrity Protocol. And this uses a system of per packet keying. What does that mean? So a packet is basically a unit of data that is passed through a network. And so with per packet keying, it generated a new wireless key for every packet that was passed through the network. WPA has its own flaws. Like, it can be intruded with this, well, strangely, with this supplemental program that they had. It was an addition. So WPA had this other thing that they attached onto it, Wi-Fi protected setup. And strangely enough, this is not part of the actual WPA, but it's the one that all the software that you can find online to hack into networks, they go through Wi-Fi protected access, or setup, sorry. And yeah, and then the newest one that's available is WPA2. So it replaced the TKIP with CCMP and AES, and this is it's been proven to work a lot better. It has very little vulnerabilities, and well, it still has a gaping hole with the Wi-Fi protected setup. But the only people who should really be concerned about this is the ones who operate with large enterprise level networks. I mean, with the current computing technology, you could probably intrude into a network protected by WPA in about 2 to 14 hours, depending on your processor. And yeah, so if you're really worried about this, you can disable it. If you you can disable the Wi-Fi protected access. That was the problem with this one too. You can flash your network distribution or your Wi-Fi distribution so that it doesn't support it. Yeah, that's all about.
Okay. Our prototype couldn't have worked without all of the connections that we did. Everything had to be placed in the exact spot. Even if we moved it one space down on the breadboard, it wouldn't work, as we figured out during the tested it. So there are 4 main power supplies that go from the camera to the Arduino and to the breadboard and the Wi-Fi. There's TX, which is transmitting. So the wire that goes from the camera would go to the breadboard, and there's also an RX, which is receiving, and you would just connect that to the breadboard also. And there's also ground and power. When you're connecting the Arduino to the breadboard, you have to you see the bottom 2 wires that are connecting to the breadboard. One of the black one is for power, and the red one provides 5 volts to the breadboard. And yeah, the Wi-Fi shows on top of the Arduino.
Also, I just want to add one thing. So just to clarify, this is the breadboard. That's mainly the brain of your program. That's the plan. So basically, whatever you want to do, you put it over here, and this is kind of like your arms and your legs. Basically, they're the executors of the whole your whole plan. And so what she was mentioning was how we connected this to this so that it could all function properly.
Yeah. So the blue is the negative terminal, and the red is the positive terminal. And here it's all connected through columns. Right, yeah. So it's connected vertically, so that if you put 2 things right next to each other, they wouldn't be. But if you put it if you connect it vertically, like internally, it's all connected. So yeah.
So current flows from here, as sort of mentioned, but then in the actual terminals, they
Yeah,
flow
so-
from
Yeah. So you have to do it horizontally.
Okay. So now we're just going to mention a bit about our web server. So here's a small video.
Hello. In this video, I am going to show you how to turn your Windows 7 client computer into a web server by installing the Internet Information Server. This feature will come in handy if you'd like to serve up web pages on a small scale to the internet, or even more likely have private web pages for your home office or small office environment, calling that an intranet. So we're going to start out by installing Internet Information Services. I'm logged on to my Windows 7 virtual machine running in VMware Player with administrative privileges. I'm then going to click on Start, and then I'll click on the Control Panel, and I need to go into Programs, Programs and Features, and then turn Windows Features on or off. The Windows Features dialog box comes up, and we can turn Windows Features on or off from here. And if I expand Internet Information Services, and then expand the World Wide Web Services, I have the opportunity to check common HTTP features, which is important, health and diagnostics, which is important, and security, which is also important. From here, I also would like to add the management tools. So if I expand Web Management Tools, I can check the box to add the IIS Management Console. This will allow me to manage websites. I'm then going to click OK, and this is going to add these features to my
Well,
Windows
I mean, you
7
get the gist of
computer.
it, so
So
we
I'll
can
fast
just
forward through this portion.
And we're going to explain later why we're showing this video and why we incorporated a web server into our design. It was actually a really crucial component.
Well, you will make the PowerPoint accessible to you if you want to access this.
Okay. And so now, as many of you have noticed in your scientific investigations in school and in after-school activities, perhaps the most important part is actually testing your prototype. So we did two main field tests of our prototype, where we went to our local Rocky Run parking lot, and we tested our prototype in various directions. But first, we started out small. We took a picture of us, and this is actually the first picture that we took with our camera, so it's kind of special to us, and you can see it's clear. And also then we went to Rocky Run, and then we tested out our prototype. So we put it inside a box first, so that so that all the dust can be infiltrated. And so we put it in various locations like this. We put it on the back of the car, and then this was the view that you could see from here. And then over there we put it out on the front of the car, and then we put it on the head of the car. So as you can notice, we mainly put it on various different locations. However, we soon realized after taking about 20 so pictures that perhaps just one camera might not be the solution to our problem. We might need two, so that we have two different locations, and we can receive input from both sides in order for the driver to have a better working with this.
And another solution we came up with was also have the camera installed just in the center of the car, and then have a servo motor that comes in with the kit. If you buy a full kit, you can use a servo motor to rotate the camera around. So if you stream live video, you can see just all around the car, so all the views.
And that also corresponds with our 360 vision, because we want you to be able to see all 360 degrees. Okay, and also let's go. Okay. And as I mentioned before, we mainly did another test as well, and that was actually under various inclement weather conditions. So, and so it was kind of interesting to see how it was yeah. So it was kind of interesting. So as you can see, this is outside. So we're just going to scroll through the pictures one to see. It was snowing that time, so it was actually really interesting to see how our camera solution would work with the weather. And so again, we put it in various different locations. And so, yeah, mainly that's. information here, you might be asking, why is this important to you? Why are we telling you all this? So mainly first, I just want to start off by the mission scope of eCybermission, which is what the whole eCybermission branch wants us teams to do, is that technology is the creation or modification of a device or tool to solve a problem or improve a pre-existing solution to a problem. Teams must research, hypothesize, experiment, and use science, technology, engineering, and mathematics to solve a problem in the community with technology. Thus, it was vital for all of us to, address a really arising issue in our community that has been going unnoticed for quite some time, but needs to be addressed. And we felt like eCybermission provided us with the perfect opportunity to do so. So as Didier mentioned, we had various brainstorming sessions, and one thing that came up was the issue of blind spots, which is basically what our whole solution stems off of. And in order to research more about this and understand why it's such a detriment to the community, why is it such a big problem today, and so we also realized that with over 250 million vehicles on the road in the United States, there are over 500,000 two-vehicle lane change crashes annually, and that's annually. Like I know that when I read that, I was like, whoa, this is not good. In addition, due to limited visibility to drivers while reversing, there have been nearly 100 fatalities each year. I think that as a society, it's too much for us, and it was really vital to address this issue. But also, as Divya mentioned, despite the fact that a federal law has been passed in 2008 in order to mandate this, the manufacturers have been providing much resistance to this issue. And so we thought that, why not we create a prototype for a solution that will be easy, cost, accessible to the community, because that's the main thing. We want it to be accessible to everyone. And also, make it a little creative. And also, the main problem, the why this is such a problem is because there are many children, there are many seniors in our community, and we should take care of everyone, as you saw in the video. And also, we plan to create a simpler, low-cost solution. And so we also hope that with our solution, we can all come together as a community more. We can all go hand in hand, and hopefully, by the end of our testing of our solution, you will be the happy driver right now.
Good job.
So now, just really quickly about blind spots. So one problem with cars today is blind spots, and so basically what it is when you're changing lanes, your mirror can only get so much of what's behind you, and so as you see, the mirrors can catch the red part. But when the car is in the middle, this car cannot see that car, and that's where most crashes occur. And so our goal is trying to be able to get 360 vision, so you can get in the sides of the cars too. So rear view cameras aren't only for backing up, but they're also for lane departure and changing lanes.
What we mainly focus on. Perhaps, and also in one of the questions in our mission folder, as Malika mentioned, was also that if you as a team have more time in order to clarify your solution, what would you do? And I feel like we would all make it a little bit better. We would all add another camera as well, and also what they mentioned, various other uses for it.
So rear view cameras today cost between $100 and $400. If you want to add it on to your car, but our solution costs tops $50 maybe. So because it utilizes all the latest.
I think that's a really nice improvement. And also, one thing that we want to end with is our journey, because as many of you may know that the journey, that the end product is not important. It's the journey that really matters. And I think that when we all had our first meeting in November, it was like whoa, such a big task at hand. How are we going to do all this? But I think that all of our team members' dedication, inputs week after week really helped in that. And I'm really thankful for this. So we're just going to share one main experience of our journey so far, as it's ending in about a week. So,
I loved this entire eCybermission project, and we faced so many different problems, but I loved it how we all came together and found one perfect solution to the big problem that we have to face.
Well, I actually feel like I learned more from these girls than actually any book or anything, because everybody we all take different courses and everything, and when everybody integrates their ideas, you actually learn way more. And I it's like the application that really matters, and I felt like I learned a lot from having like all three of these.
When we put our views together, we came up with something that was way better than than any of us could have done individually, and it was just a really great experience. We learned a lot of things, wetting our feet in many areas, and just I didn't know anything about electronics when I came in, but now I can say that I can make a circuit.
For me, I honestly think the best part is, on our daily rushes, we often forget to take a glimpse into what's really important, and the different problems that are affecting your community. Instead, we just complain about it. And I think that, for me, it was just that journey of trying to find the problems in our community, identify them, and then trying to really see why is that such a problem today. And also why are we making such a problem, and also how we can help you all. And so I think that was also my favorite part of the journey.
Okay, so we have some pictures. So these are some pictures we took today using our camera.
So as you can see, our camera was right over here, and we were just clicking it.
So it's literally that small. It's like definitely like half the size of a penny. It's like the camera's actually really small, and that's a good part because it's easier to get angles. Like even if you move it this much over, you get way more.
It gives you a wide range of view.
And it's also really portable too, which is perfect for your car.
So by using a servo motor, like just like tilting it by like 5 degrees could even get like a whole new view. So.
And that would be our next step towards this.
Yeah.
So those are the pictures that we took.
Good job, guys.
And also now, if you guys have any questions, concerns stuff, any questions? Okay, also, so since you guys have any questions, I want to ask you, how many of you have noticed the problem of blind spots in our community? Just like raise your hand. Yeah, see, as I think that it's such an ongoing occurring problem, I think that we really needed to take an effort towards it.
You can always just like turn around and look, but once you have technology, you don't have the chance of human error that can make really detrimental mistakes.
So any questions? Any questions on their solution? Yeah.
What are the privacy laws around the camera?
Sorry?
Do you have any concerns around privacy law putting a camera on a car that has 360?
Well, it would be the same thing as setting up a rear view camera that they already have placed in some cars. Like you're not really logging it. You can upload it and always erase it.
What is the backup plan for the system? Like if something goes sorry, that's about
Well, I guess as Rachel mentioned, you had we were going to install multiple cameras, and even if something goes wrong, you still have like previous pictures that you streamed. So.
Yeah.
And backing up is kind of like it's something that just you need just an instant for. You just need that video just so that you can see what's behind you in certain angles. It's like they already have visibility. Like you have your side view cameras and all these. But why do we need a camera? Because that can offer more view than just these mirrors will. So.
And also that's why we want to install the server.
Where are you?
How are you delivering the picture to the drive? What was your plan for how
So
the
that was
time would
actually
see?
the web server.
Yeah, so what we wanted to do was, do you want to explain it? Or display? So
Yeah, so we, when we were testing, we connected, as you see here, we just did that, and using the Wi-Fi shield, we connected it to the computer, so all the pictures that we would have on the camera would go into the computer.
To make this more accessible, we could also do this on, most people have smartphones like nowadays, so like we could easily just like make an app that connects the camera to the phone, which is iFi. So if we added an iFi tip on there, we could just do that, and it's pretty easy.
Well, I guess what we're trying to do was leverage the current technology that people have today. So you could just pull up your smartphone and open up the server, and the camera could automatically, using the Wi-Fi, upload those pictures onto that server.
There's various ways to set up that web server.
You might be thinking that the pictures will be delivered late and stuff, but like by using motion picture, which is like, do you want to explain the concept of like motion picture? Like,
Oh, well, yeah, if you, the whole principle is that, you know, in certain animations, if you flip, I mean, you can stream live video. Another option is that using this principle, you can take lots of pictures really fast, and then you flip those, yeah,
the icons.
yeah, and if you flip those really fast, you can see the moving images. Yeah. Did you have a question?
So you are using the Wi-Fi, are you using cell network? What exactly are you using from the camera?
So you're connecting to the network using that Wi-Fi shield. Like, so on the Arduino, when you put the Wi-Fi shield on, that is what enables it to connect to a network. And using that, you have access to the internet. You can send the pictures there.
That provides the Wi-Fi itself. Like you don't have to connect it. As long as you connect the board to that shield,
Yeah.
you'll get Wi-Fi.
There's actually like there's a program that we did we just had to edit it. You add in the Wi-Fi that you're supposed to be looking for. Like your phones will have a hotspot probably. Most do now, and you can connect to that Wi-Fi. So when you do the program, you just enter in the Wi-Fi that you want that Wi-Fi shield to look for, and it'll connect to that. Then send the pictures there.
I just noticed you had a wire for that one. Is that the power
Oh yeah,
cable?
this is well, this is what we have for now. We had the wireless done and the server up, but we just had the server.
The problem was
Yeah.
that it was you can take the picture, but you can't see it, and so
We're
you
still
can't
working
see it
on
on the
that.
server, which is not helpful for us.
Well, this was for demo purposes, just so you could see how the camera was functioning. The Wi-Fi shield, we came up to the point where we could actually connect, but just the problem of uploading the pictures, that was what we were working on.
And that's our next steps also for research.
So if the camera is always taking pictures and they're streaming into your phone or computer, wouldn't they fill up your memory?
It's not always taking pictures.
It's an app, first of all. Like I don't think the pictures actually get stored because then, yeah.
It's
more
an
like
app
a video.
or a
Yeah,
server.
it's more like a video.
It's
A live
based
one.
based on your preference also.
It would be taking memory if you uploaded it, or if you sent it, if you saved it into your phone's photo folder, but you're using the internet, so you're just uploading it onto a server, and that can take data. Like that will take very
So
long.
basically, so you can see it immediately, you can use your function, and you can go back and you'll never see the picture.
I'm a little confused about what's connecting to what. So I understand the Wi-Fi shield goes on the Arduino and that gives you Wi-Fi access. Are you setting this up as your hotspot in your car and
Yes.
that's your network?
Yeah,
So,
exactly.
so this and the Arduino are connected
Wirelessly,
together,
yeah.
not through any other third party. We're not going out to the internet. We're just a local network.
Exactly.
So the Wi-Fi shield will be programmed to like connect to your hotspot, which is we tried testing that with our laptops. We connected. That's where the WEP and all that came in. WPA2, and we learned how to connect to all the different servers and stuff. And we went through a lot of like web server connection testing. And yeah.
Do you have time for some testing?